Okay, now we're going to discuss how to select variables for the regression when you have a bunch of them. You have a whole lot of variables, independent variables that can be used to forecast sales. Not all of them may be quite good in predictive nature. So which ones are good and which ones are not good, and which ones should be included and which ones should be left out. So that's what selection of variables is, and we're going to spend a lot of time on that. Now, the first step in selection of variables is the concept called multicollinearity, which can be used to prune down the number of variables we have. Unfortunately, your textbook discusses multicollinearity after having discussed the selection of variables, and because of that it's kind of convoluted. So I'm going to take a different approach. I'm going to first discuss multicollinearity, and then we'll go back to selection of variables. So we start with multicollinearity, and once again remember, multicollinearity is a concept that can be used to prune down the variables, and it refers to correlation among the x variables, among the independent variables. Okay. There are two kinds of correlation. One is correlation of these x variables with the response variable y, the variable that we want to predict. And that correlation is good. You want the predictor variables to have high correlation with y, so we can use that correlation for predictive power. Okay. That correlation is good correlation. But if the x's are correlated among themselves, then they will be competing with each other for that same predictive power, and because of that, certain unfortunate situations can happen. So that correlation among the x variables is called multicollinearity. Okay. When there is multicollinearity, what may happen is, so like for example, age and experience. Okay, you want to predict salary of an individual, and then we have age and experience among other variables in the group. Now, as people grow older and older, their experience is going to go up also. So these two variables are going to be highly correlated with each other. Okay, so taken individually, maybe that has a high correlation with y, and it may be a significant factor in the regression. But when you put both of them together, they are fighting with each other for predicting y. So in your regression analysis, they both may end up being not significant and make you drop both of them out of the regression analysis. Of course, age and experience, we can immediately readily see that at least one of them should be there. But what if you have a bunch of variables and you're trying to prune them down, and you don't really realize that there are a couple of variables that are competing with each other in terms of collinearity. So there must be a systematic way, instead of relying on your conceptual knowledge, okay, which is good, we need that too, and we want some numerical results also to help us determine whether there is multicollinearity as well. So we're going to start with running some correlation analysis, and then just by looking at the correlation we can see whether there is multicollinearity or not. So we can use the data analysis correlation for that. And then there is another statistic that we can compute, and that is called variance inflation factor, VIF. So the VIF, variance inflation factor, is given by 1 over 1 minus R squared sub j, where R squared sub j is the coefficient of determination from a regression with x sub j as the dependent variable and all the remaining x's as the independent variable. So you have the bunch of x's, so you take the first x and make that the y variable and have all the others as your x variable. Run a regression, you find a R squared value. Okay, and then plug that into this, and that gives you VIF of the first x variable. Now do the same thing with the second variable. So now we put the x1 back, now take x2 out and make that y variable, and let all other x's be your independent variables, and repeat that. So if you repeat that for all the k variables, and you'll get the VIF values for each of them. Okay. Now let's look at what the VIF value will be like. Suppose if x variable, a given x variable, is not correlated with all the other x's. That means a good thing. Okay, so there is no correlation. There is no multicollinearity. In that case, this r squared value will be very small. At the extreme, it will be 0. So, which means the VIF value will be equal to 1. But on the other hand, if there is multicollinearity, like if this x variable is highly correlated with some or few or all of the other x's, then you will see a very high r squared value. Now at the extreme, this is going to be equal to 1, which means you end up with 1 over 0, which is an infinitely large number, undefined infinitely large number. So VIF will increase. So larger the VIF value, the more prevalent the multicollinearity problem is going to be. So you want to run this VIF value and see which variable has a very large VIF and maybe throw that out, remove that from consideration. So we're going to look at correlation using the data analysis correlation command, and we're also going to look at VIF, and we don't have to run these regressions one by one ourselves. And I have set up a macro for this, and VIF is an array function macro. So you can use that VIF array function to determine what the VIF values are for each of the x's. If you're using SAS or SPSS software packages dedicated for statistical analysis, you can simply check whether that you want the VIF value, and it will generate the VIF value for you. But in Excel, you have to use the user-defined macro that I have set up. So that's what we're going to do. We're going to run the VIF step by step. So initially we take the entire axis, run the VIF, and then we drop, if there is a problem, drop the largest VIF out, and we also need to look at the correlation to see which variable should be eliminated, and then you run the VIF again. And if the multicollinearity problem persists, then remove the next highest VIF value after looking at the correlation. Keep doing that until you get down to a reasonable set of variables with VIF not exceeding, preferably not exceeding 10. Okay, there is a thumb rule that your textbook uses, and that is if sample size is less than 30, then you don't want the VIF to be greater than 5. If n is greater than or equal to 30, then you can allow VIF to go up to 10. So sometimes you can. This is only a thumb rule. This is nothing sacred about this. So you have to be you have to be somewhat flexible with this. And of course, we will always drop a variable if the p-value is greater than alpha. Okay. Now let's go to Excel and look at this multicollinearity analysis.